Let's begin by reviewing the FT-IR spectrum collection process. You're going to need a few things, including clean solvent, your dried sample, some Kimwipes, and 2 clean pipettes. We're going to need 2 clean pipettes, so we have one for the clean solvent and, of course, one for your sample. Now, to prepare the sample, we want a very concentrated solution of that dried material in your solvent. So add just a few drops of solvent, just enough that you have a very dark concentrated solution. This is what we're going to be using for our IR analysis. Next, we need to clean the crystal. Now, the crystal is made of zinc selenide, and it's the very, very small button of glassy-looking material at the center of the ATR. You'll be using your clean solvent and also a clean Kimwipe. Add a few drops of clean solvent, and then blot the solvent up off of the ATR using the Kimwipe. It's important to never touch the crystal with your pipette. Now we're ready to start the experiment. You'll begin the experiment by going to the laptop computer and clicking Next on the Microlab experiment. It will then run a quick diagnostic on the crystal and collect a background. This is why you want a clean crystal, to be absolutely sure there's no signal being collected in the background. Next, you'll be directed to load your sample. When loading your sample, you'll use that concentrated solution that we just made, applying just 1 drop of solution to the center of the crystal on the ATR. So here's my solution, and here comes my 1 drop, being careful not to touch the pipette tip to the crystal itself. Now I'll wait a few seconds for that solvent to evaporate, leaving behind a thin film of the solid solute material. You'll want to be sure that that film creeps over and actually is on top of the crystal, because that's where the experiment will happen. Now we're ready to collect a spectrum. We do this by going back to the laptop computer and pressing Next in the Microlab software. You'll see some real-time scans of your sample, which your TA may grab as a screenshot for you to analyze. And as long as these are not changing through time, you know you have a stable dried sample, and this is indeed the IR spectrum of your organic material. Finally, we need to clean the crystal again to be sure that it's ready for the next user. We do this the same way we did previously, adding a few drops of our assigned solvent and then cleaning around the crystal. Notice that I'm rubbing along the metal parts of the circle, but not the crystal itself. Once I've cleaned the metal ring around the crystal in this way, I can then finish cleaning the crystal by blotting with a Kimwipe. The zinc selenide is very fragile, and rubbing it back and forth or wiping it can cause abrasions, which will reduce the instrument sensitivity. Now we're ready for the next user.